Yes, the third layer of OSI model is network layer, and the network layer is also responsible for the physical movement of data in the network from one point to another. And the main functions of network layer is logical addressing and routing. So, what network layer does? The network layer controls the operation of the subnet. Net means network, and what do you mean by the subnet? Subnet means the part of the network in which part operation is happening, that is known as the subnet. A key design issue is determining how packets are routed from source to destination, and the routes can be static and it can be dynamic. So there are two types of routing algorithms can be used: static routing and dynamic routing. And if we talk about the addressing scheme which is used at the network layer, and that is logical addressing. So when we need logical addressing, when we need physical addressing, so when we are working inside a network within network boundary, so we need only physical address. But if we are going beyond the network boundary, if data is being transferred beyond the network boundary, another addressing scheme is also used, that is logical address. Or we can say there are two types of logical addresses which is used: IPv4 and IPv6, two versions, Internetworking Protocol version 4 and Internetworking Protocol version 6. IPv4 is 32-bit IP address and IPv6 is 128 bits IP address. So what is the difference between these two IP addresses? In IPv4 IP address, 2 to the power 32 different devices can be uniquely assigned a logical address. But in IPv6, 2 to the power 128 devices can be assigned unique IP addresses. So this is known as address space of IPv4 and IPv6 respectively. So no two devices at a time on the internet can have same IP addresses. So each and every device which is connected to the internet must have unique IP address. If there are two devices having same IP, then there will be IP conflict. When we talk about the routing, there are two types of routing algorithms which is being used: static routing and dynamic routing. Why it is known as static routing? In static routing, for the transmission of packets, route is decided in the advance. Means it does not depend on the current traffic and current topology. But in the case of dynamic routing algorithms, the route of the packets route is decided taking in the account these parameters, that is current traffic and current topology. So in this way routes are decided in the network layer. These are the two main functions of the network: logical addressing and routing. The data which is used at this layer is known as packet. In this diagram it is shown that from transport layer, L4 data means data at the layer 4 is received by the network layer, and at the network layer, when network layer appends a header 3, header 3 means header at the layer 3, and combinedly it is known as packet. So all these packets are processed and handed over to the next layer, that is data link layer, and this L3 data is handed over to the data link layer. In the previous layer we have seen this transmission of data, how it is transferred, and the data at the layer 2 is known as frames. Data at layer 3 is known as packets. So in this way it is transferred by the sender device and received by the receiver device, and the reverse processing is done. Okay, so how it works. Network layer, this is the network layer example. This is a network. There is one topology, bus topology, another topology is ring topology. Here below it is shown ring topology, and in network layer example there is a device A and E in the bus topology. The number which is showing here is physical address, and the alphabet is known as logical address. Another device is having physical address 87 and the logical address E. So I already told you that if we are going beyond the network boundary, we need another addressing scheme is known as logical addressing. So here logical addresses are A, E, which is shown in this diagram, and this bus topology is connected with this another ring topology with the help of a router. There is a box and R is written within this box, and this R stands for router. A router is the combination of hardware and software which decides routes with the help of maintaining tables at this level. Okay, so this is shown that source is A, so the physical address of A is 10 and the destination's physical address is 20, and the logical address of sender is A and the logical address of receiver is P. So when this packet is transferred from this bus topology through this router, it is received in the ring topology. So one link of R is T, its logical address, and its physical address is 99, and the another device in ring topology is another router which is connected with this ring topology is R, and its one link's physical address is 33 and logical address is N. So here we can see in this packet only physical addresses are changing, but logical addresses are fixed. So we can say that when the packet is transferred from one network to another, is going beyond the network boundary, only physical address changes, logical address remains same. This is the another part of that network. In the last, the device, there is a topology is used in this. This is a bus topology. In this there are two devices P or M. These are the logical address, and the physical address is 95 and 77. Finally the packet arrives and received by P logical address, and the physical address of this computer is 95. So in this diagram it is shown how the physical address changes and the logical address remains same. So we will see in detail in the later videos. And this is the functioning of the brief discussion of the network layer. The next layer is transport layer. Transport layer is the layer which is responsible for service point addressing. Service point addressing means if data is transferred, if there are so many pages, if there are 10,000 pages, so 10,000 pages is not transferred at a time. It is decided that how this data is, which is the data which is received by the session layer, how it is converted into different sections, and each data is divided into segments, and each segment transport layer adds its header also. Okay, so transport layer is the layer 4. Please do not touch means transport layer is layer 4, and layer 4 also adds header to each its segments. So whatever the data is received by the session layer, transport layer converts into different segments, and these segments are transferred by the transport layer and the assembly at the receiver end. These are collected, and it is not guaranteed that the sequence in which the segments are transferred in the same order they are received. So there is the requirement of reassembly also. So transport layer is responsible for segmentation and reassembly. And the next is connection control. Connection control means which device will use the connection. If there are too many devices are connected in a network and they wants to use the same communication channel, which will use that connection. So this is the responsibility of transport layer. Which device will use the connection. The next service of the transport layer is flow control. In flow control, it is guaranteed that there should not be mismatch of speed between sender and receiver, so that there should not be overwhelming of the data. How we can understand the concept of flow control? If the sender is transferring at the speed of 1 gigabits per second and a receiver is receiving the data at the rate of 10 megabits per second, so sender's speed is relatively very high, so receiver will not be able to process the data at the time at which it is sent by the receiver. So there should not be synchronization between the data. So it is also required flow control. And the last characteristics of the transport layer is error control. Error control is used for the error detection and error correction. So you can say that flow control, error control are also used by the data link layer, and the transport layer also uses flow control and error control. So how these layers are different? How the functioning of these layers are different? how error is controlled at the data link layer and how the error is controlled at the transport layer. So what is the difference we are going to see? If there are four devices A, B, C, D, and the device A wants to communicate with the device D, so error controlling across multiple links, that is across A, B, B, C and C, D. For this, data link layer is responsible, and transport layer ensures the flow control or error control across the sender and receiver. So for this, error control across the A and B and flow control across the A and D is responsible for transport layer. And for controlling these things across multiple links, that is, if sender is A and receiver is D, so data will not go directly A to D, it will go through A to B, then B to C, then C to D. So these are the hops. One hop, A, B is another hop. So means hop to hop delivery, node to node delivery, and across this node to delivery error control and across this node to node delivery flow control responsibility is of transport layer. In this next slide, it is shown that how the actual communication happens. How the actual communication happens. There are two systems in this diagram. One system and another system, and both systems are connected through the internet. Or we can say that these two devices are in a network. I have already told you that first three layers of OSI model is responsible for movement of data physically from one point to another. So data is for the movement of data from this first device A to the second computer B, say only first physical layer, data link layer and network layer is responsible. But actual communication happens after this. The fourth layer is transport layer. Transport layer is used for performing actual communication. What is actual communication? Process to process communication is actual communication. In first device, it is showing in this slide that in the first computer there are three processes. Three processes running. Processes means running application programs is known as process. So there are three application programs are running, and the another device is also having three application programs running, means there are three processes at one device and three processes are another device. So actual communication happens when one process communicates with the another process. So performing this process to process communication, transport layer is responsible. And for this transport process to process communication, transport layer uses another address that is known as port address, and the port address is 16-bit address. 16-bit address means there are 2 to the power 16 different port numbers which are used for different purposes. Okay, so when we talk about the ports, this port, that port, means we are discussing about the port numbers. So there are some specific port numbers are fixed for some specific purposes. So we can say that how the actual communication happens with the help of transport layer. So which layer is responsible for process to process communication? Transport layer. Which layer is responsible for framing? Data link layer. Which layer is responsible for logical addressing? Network layer. How many layers are responsible for movement of data physically in the network from one point to another point? First three layers of OSI model. How many layers are network support layers? First three layers are network support layers. Upper three layers are user support layers. Transport layers acts as a bridge between user support layers and the network support layers. The next layer is session layer. Session layer is the fifth layer. Session layer is the fifth layer of the ISO OSI model. The session layer is used for maintaining the dialog, control, for maintaining this session. It takes the data from the presentation layer, that is the L6 data, and before transmitting data, it add synchronization bits after certain data, and it also adds the header controls, header stores the control information regarding sender and receiver. What is this SYN? SYN means synchronization bits for the synchronization of data. So how we understand with the help of example. If there are 10,000 pages we have to transfer. First we transferred first 100 pages, after that synchronization bit. After that 101 to 200 pages, after that synchronization bit. After that 201 to 300 pages, means in one lot there are 100 pages. So if there is any error at any point, say for example, if during the transmission of pages from 201 to 300 there is an error is detected, so in spite of sending all the data starting from page number 1 to 300, we have to send only that specific pages from 301 to 200. If there is error between 301 to 400, so we have to send only that data, because there is checkpoints or synchronization points after every 100 pages. So it is acknowledged. So this is the functioning of the session layer. It also maintains the dialogue between the sender and receiver. For example, if we log in Gmail account and if we do not active, we are not doing any activity 30 minutes, 1 hour. So when we refresh, it shows that session is expired. So this is the responsibility of session layer, how the session is maintained, how the connection is established, how his connection is disconnected. So this is all the responsibility of session layer. Okay, after this session layer, next layer is presentation layer. Presentation layer is the layer 6 of the OSI model. The functions of the presentation layer is translation, encryption and compression. Translation means how the data is translated from one form to another form for the security purpose, how it is encoded. Next function of the presentation layer is encryption. Encryption means how the data is, how the different transformation is used for the encryption, so that it cannot be, so if it is hacked by the third party, it cannot be read easily. So this is also the responsibility of presentation layer. And the third responsibility of presentation layer is compression, how the data is compressed, what will be the size of the data, that all the responsibility of this presentation layer. So there are three functions of the presentation layer is translation, encryption and compression. And this, in this slide it is shown that how the data from application layer is received. L7 data is received by the presentation layer, and the header 6 is added with the data, and after that it is forwarded to the session layer by the sender side and the receiver side also. Okay, and the next layer is application layer. Application layer is the layer 7 of the OSI model, and the user directly interacts with which layer? With the application layer. We can say that user interacts with the application layer directly, and user hands over the original data to the actual application layer, and after that it applies its own functions and transfers the data to the presentation layer. There are so many protocols that are used at the application layer, that is simple mail transfer protocol, SMTP, file transfer protocol, FTP, telnet, telenetworking for the remote login, TFTP, trivial file transfer protocol. These protocols work at application layer. Now the summary of different layers of this OSI model, starting from application layer. To allow access to the network resources, application layer allows access to the network resources. Next layer is presentation layer, which is responsible for the translation, encryption and the compression of data. Session layer is responsible to establish, manage and terminate sessions. I have already told you this, how it is session managed. Transport layer is responsible for providing end-to-end message delivery and error recovery, or we can say process-to-process delivery. Network layer is responsible for transferring packets from source to destination to provide internetworking. Next is data link layer. Data link layer is responsible for organizing bits into frames, and it provides node to node delivery, or we can say that hop to hop delivery of the frames. And the first layer is the physical layer. There are so many characteristics of the physical layer. I have previously told you. Physical layer is responsible to transmit the bits to provide its mechanical and electrical specifications. So these are the summarized summary of layered functions of OSI module. Thank you.